Physics has shaped our world in ways we can all agree. Rockets to space, the phone in your pocket, and even the electricity powering your home. It's a science that has revealed the hidden rules of reality. But for every riddle physics has solved, there are others that remain as stubborn as ever. Today, we'll explore some of the most perplexing unsolved problems in physics. These aren't just academic puzzles, they're gripping stories of discovery, frustration, and perseverance. Each one started with a simple question, a flash of inspiration. But along the way, something didn't add up. Let's start with something you've seen, maybe even played with before: magnets. Magnets are everywhere: fridge doors, phone speakers, even in MRI machines. And you've probably seen how every magnet has a north pole and a south pole. But here's the big question: can a magnet have only a north pole or only a south pole? This idea was proposed in 1931 by physicist Paul Dirac. He called it a magnetic monopole. Dirac wasn't just guessing. His equations showed that if monopoles existed, they could explain why electric charge always comes in neat, whole number amounts. It was a revolutionary idea, and it sent physicists on a hunt. They built particle detectors, scoured space, and even examined ancient rocks. But they've never found one. To this day, the search for magnetic monopoles continues. If found, it would be a monumental breakthrough, changing our understanding of electromagnetism and the universe itself. While physicists search for a particle that might exist, did you know that one day we might stop existing because we are made of protons? Protons are everywhere, in every atom of every object you've ever touched. For a long time, scientists believed protons were indestructible. But in the 1970s, theories like the Grand Unified Theory, or GUT, suggested that protons might not be so eternal after all. To test this idea, physicists built enormous underground tanks filled with pure water. If a proton decayed, it would release a flash of light and these detectors would catch it. But after decades of observation, not a single flash has been found. Maybe that would mean protons never decay, or it might also mean they take billions of times longer than expected. Scientists are still watching, because if they ever catch a proton decaying, it would change everything we know about the future of matter and the universe. While scientists were figuring out particles might decay, they stumbled upon another problem: some particles are much harder to detect. And this was the dawn of the most famous mysteries of all: dark matter. Look at a galaxy spinning in space. By all logic, it should be flying apart. The visible matter simply isn't enough to hold it together. And that means something unseen is holding it together like a glue. The story begins in the 1930s with a Swiss astrophysicist named Fritz Zwicky. He was the first to notice that galaxies weren't behaving as expected. He termed the invisible glue dark matter. Since then, scientists have tried to identify what dark matter is. Could it be a particle, a field, an unknown force? No one knows. But it makes up 27% of the universe, and finding it could rewrite physics forever. While dark matter pulls galaxies together, something else is pushing them apart: dark energy. In 1998, scientists made a discovery that stunned the world. The universe isn't just expanding, it's expanding faster and faster. And scientists thought, something must be driving this acceleration. They called it dark energy. Dark energy makes up a staggering 68% of the universe, and yet we have no idea what it is. Some think it's a force tied to space itself. Others believe it's a sign that our understanding of gravity is incomplete. Whatever it is, it holds the key to the universe's ultimate fate. As if that wasn't enough unsolved riddles, frustration was starting to creep in because scientists seemed to stumble upon newer problems, such as the discovery of neutrinos. The big question here was, do neutrinos have mass? Neutrinos are particles so tiny and elusive that they pass through the Earth like it's not even there. For years, scientists thought neutrinos had no mass. But in 1998, something surprising was discovered. Neutrinos change as they move, and the only way for that to happen is if they have mass. Detecting these tiny shifts required some of the largest detectors on Earth, huge tanks of pure water buried underground. Scientists now know neutrinos have mass, but how much mass is still a mystery. Finding out could lead to a deeper understanding of how the universe evolved to its present state. In this quest to unravel the composition of the universe, another irritating question stepped in. We all know what matter is. Antimatter is the twin of almost all the subatomic particles that make up the universe. It's made up of antiparticles, which are the partners of the particles in ordinary matter. For example, an electron has a negative charge, while its antimatter partner, the positron, has a positive charge. Antimatter and matter cannot coexist for more than a fraction of a second because they collide and annihilate each other, releasing large amounts of energy. When the universe began, there should have been equal amounts of matter and antimatter, but there wasn't. Matter won, and antimatter was wiped out. Why? No one knows. Particle accelerators have tried to recreate the early universe, but they haven't solved the riddle. If we figure out why matter triumphed, we might unlock secrets about how the universe began. Most of all, these questions seem out of mind, just overthinking and running away from reality. One scientist, however, decided to stick with reality, hoping to unify the universe. But to him, the hurdles were not different. The problem in spot here is the famous, the theory of everything. Einstein spent his final years searching for a single equation to explain all the forces of nature. This is because his theories of relativity, which were accurate in describing the universe, seemed not to agree with the theories of quantum physics, which were new at the time but also precise in describing the behavior of tiny particles. He believed that there was something, an equation or relation, that would unify the two. After his death, other scientists took up the challenge, but no conclusion has been made to date. One approach is string theory, where particles are tiny vibrating strings. Another is loop quantum gravity, which imagines space and time as woven loops. While both ideas are elegant, they are unproven. Physicists hope that one day this theory of everything will unite our understanding of gravity with quantum mechanics. Let's travel back in time to 1911 and witness as physicists make a big leap in history that would later present a big problem in 1986, 75 years later. In 1911, superconductivity was discovered, materials that let electricity flow with zero resistance. But it only worked at super cold temperatures. Then, in 1986, a shocking discovery, superconductivity at higher temperatures. It sparked a global race to understand how it works. To this day, no one fully understands why certain materials become superconductors at relatively warm temperatures. Solving it could lead to super-efficient power grids and quantum computers. At this point, you are probably tired and frustrated on how much is not yet solved in physics. In less than 30 words, I want you to also know that moments after the Big Bang, the universe expanded faster than light in an event called inflation. But how it started, and why it stopped, are questions that remain unanswered. Physics is a story of triumph and mystery. Each unsolved problem is a call to curiosity, and maybe you are the next person to break a barrier that most scientists stumbled upon. So keep doing what you are doing, keep learning and discovering. One day the universe will look back and celebrate your work. Which of these puzzles do you think will be solved first? Drop your guess in the comments below. And if you are still not subscribed to this channel, please subscribe so that we may continue to bring to you more interesting stories about science. Until next time, stay curious.